All right, so I want to find the max-min value, the axis of symmetry, the y-intercept, and the zero or zeros if we have it, okay? So what I like to do is I like to try to find my y-intercept first because that's the one I'm used to finding first. So do we know the point where the graph crosses the y-axis? Because we're looking at the y-intercept. Well, if I look at my graph, I notice that the parabola crosses the y-axis at -9. Okay, so our y-intercept is the point 0, -9. Okay? Now, I know the graph is positive because it's going up, which means to me, I should already know we have a minimum value. Okay, a minimum value. In this case, our minimum, our lowest point is that point right there, which is again 0, -9. Okay, so that's our minimum. Now the minimum value is written as y equals the y value of the maximum or minimum. Okay? The axis of symmetry is x equals the x value of the maximum or minimum. In this case, it would be 0. Now again, the axis of symmetry is that imaginary line that cuts the parabola in half, right? And if we were to take our minimum point and draw an imaginary line, we can see it's on exactly the y-axis, which means it's going to be 0. Okay, now, our zeros, also called roots, okay, are the points where the parabola crosses the x-axis. In this case, we see that it crosses the x-axis twice. Once here and once there. Okay? So those are our zeros. So we're going to say we have zeros at -3 and 3. Okay? Finding the zeros, again, comes down to just looking at the graph and seeing where the parabola crosses the x-axis. All right, let's look at another example. So, looking at this graph here. Okay, so we notice it is a negative graph because it's going down. Okay, so we can identify some stuff really easily just by looking at it. Okay, we can identify if we have a max or a min. Okay, because it turns back around and goes down. We have a maximum value at the point where it starts to turn back around. So we have a max at -4, 0. Okay? So that to us means our max value would be y equals the y value of our maximum point. In this case, our y value is 0. You can also determine the axis of symmetry from your maximum or minimum value. The axis of symmetry is the x value of the maximum or minimum. In this case, it's the imaginary line created that cuts the parabola in half. In this case, it cuts it in half exactly at -4. So we have x equals -4. If you notice, the axis of symmetry is the x value of the maximum or minimum. Okay? Now, this graph does have a y-intercept, but we cannot see it here. Okay? That's something we'll get into later. But you cannot see the y-intercept. Doesn't mean it doesn't have one. It means we just can't see it. Okay? Now, how many zeros or solutions does it have? I just put that little s in there because it could be 1 0 or it could be multiple zeros. Now, looking at the graph, how many times does it cross the x-axis? Well, we know it crosses at least once right there. So we have a 0 or a solution at 4. Just by looking at a graph, we can tell all kinds of information about a quadratic. Okay, we'll do one more, and then that'll be it for today. All right, last graph. Okay, so again, we can tell some stuff just by looking at it. We know that the parabola is positive. Okay, so that means the a value is going to be positive. Okay. Now, looking at this one, we have some values that aren't exactly perfect, but it's okay. Okay, because usually your STAR test will give you some choices, and you can play with it there. But given the graph, okay, first off, do we have a max or a min value? Do we have a maximum or a minimum? If our parabola is facing up, it means we have a minimum value. Okay, so in this case, the minimum is the point where the graph turns back around. Now, if you look here, it's not a perfect, nice, pretty looking point. However, we can get an idea of about where it's at. Okay, to me, it looks like it's at negative 0.5 and a little under 2. Okay, so I'm going to say maybe negative 2.25. I don't know exactly, but I'm just going to guess right now. Again, STAR will give you those choices to look at. So our minimum is that point right there where it decides to turn back around. Okay?